Alright, so let's talk about the remove linked list element. So you are given the head of the linked list, and then you are also given a value. You are supposed to be removed in a linked list, right? So there are two solutions. One is going to be iteration. The other one is recursion. So let's talk about the first solution, iteration. So I'm going to suppose I'm traversing from the head and all the way to the end. And then if there's a value is actually equal to val, then I'm going to change my pointer to from here to here, right? So it's going to be so if I'm changing this pointer, I'm definitely at this node, right? So I'm say current.next is actually equal to next.next, right? So current.next.next. So now my current.next is actually equal to this one, right? So this is the idea, right? So I have to be at this position to check my next pointer node value, right? Yes. So let's start coding. So I need to create a domino. So domino is going to be what? The arbitrary value, it doesn't matter. And my domino is the domino is going to be point at what? Point at head, right? So when I return, I just return dom.next. It doesn't matter, right? Because sometimes when you want to replace, the value could be 1, right? So you want to remove the 1. So 1 can be removed, right? So you need a dummy head, dummy head, something like this, right? You need to point at temporary head pointer. And I also need a iteration pointer, and this is going to be what? Head, right? So while the current.next is not null, then I can keep traversing, right? So I'm going to check. So if my current.next that val is actually equal to the val, right? Then I said current.next is actually equal to current.next.next. Else, this is exactly straightforward. Current.next, yes, current equal to current.next. While the current, sorry, this should be what? This should be dummy. This is because what? When I point at next, if the head is already null, right? Then this is not valid. So I need to point at dummy because dummy will point at head, and if head is actually equal to null, I will break out the while loop. So this is like a, like a trap, right? Something like this, right? So you need to point at dummy, and then you traversing from the dummy, and submit. All right. So for the time and space, this is a space all of 1 constant, and time all of n, traverse every single element in the linked list. So this is the first solution. So let's talk about the second solution. Second solution is recursion. So you are going to traverse, you are going to recursion yourself for the next pointer, right? So in this one, I'm not going to draw because recursion is basically based on your base case and recursion case. So yes, this is pretty much it, right? So in this one, you don't need a helper function. So you just using your current function. So if head is actually equal to the null, right? Then you'll return null. So once I know my head, right, I need to know my next, right? So next is going to be what? Remove element for the head.next val, right? So val doesn't change, and your next pointer it will based on what? The head, right? And then so now this is a tricky part. So if my current head is actually equal to the val, head.val is actually equal to the val, right? I don't want the current head. I want to return the next, right? If 6 is already if 6 the current node value is 6, right? Is equal to the 6. I don't want this one, right? I want the 3, right? So you have to think about this. So the recursion solution is like this. You are traversing all the way to the right until you hit a null, then you go backward, right? So when you go backward, you need a return value, right? So if this is the base case, if the value is actually equal to value, which is the condition case, right? Then you want to return the next, but you also need to return the head if the current value does not equal to the value, right? Then yes, so you are going to say head.next is actually equal to next. So you point at the head, the next pointer to the next value. So I'm gonna replace the head name to no. This will be so much understandable, right? So this will be exactly a solution. So if my current node is actually equal to no, then I will return no. And I also want to check my next pointer, next node. So I will say node.next. And then if my current node value is actually equal to value, right? The val, then I want to return the next one. If not, then I'm going to point my next pointer to the next one. So when I call in list and I also secure my current node value is not equal to the val, right? So submit. Alright, so this is also doable, right? So let's talk about the time and space. For the time, still all of them, right? Traverse every single element in the linked list and represent the number of the nodes in the linked list, right? And then for the space, it's constant, right? You definitely don't consider this as a space. You clean the cache later on, right? So this is pretty much the solution. So if you think this is helpful, subscribe, like, and leave a comment if you have any question. All right, peace out, bye.